And you, Alex, are located in the Netherlands, yes?
No, I'm in London actually, but the overarching sort of umbrella company that is QXIP. So yeah, they're in the Netherlands, but we're global. Like we've got people in most continents, so we're pretty spread out. But I'm personally in London now. I was in Barcelona for a long time, but I've just moved back. How about you?
I'm based in Kazakhstan right now.
Oh, nice.
Yeah, so it's quite late, but actually we are open for our users. So
Yeah. Hopefully it won't keep you up too late.
yeah. So guys are coming. I see. Hello, everybody. We will start within 2 minutes officially. And now I can explain some rules. That Q&A session would be at the end of the session of Alex. And then you can ask any questions in the chat. If you want, you can raise your hand and ask a live question. We will be glad to answer it as well. And you, Alex, are located in the Netherlands, yes? Sorry, I checked my YouTube settings. If you hear
No.
them, I don't know. Okay, we can start just 12 p.m. and we can start our session by Alex Maitland, co-founder of Gigapipe. And the session theme is breaking the vendor lock, open source observability without the traps. So, Alex, you're welcome.
Hi, thanks for the introduction. Good morning, afternoon, depending on where you guys are, everyone. Thanks for coming. I really appreciate it. As Anastasia mentioned, my name is Alex. I'm the co-founder of Gigapipe. It's an open source observability suite focused on handling and correlating logs, metrics, traces in a polyglot and unified platform. So today I'm going to be talking about the current state of the open source observability market, as well as the competitors that sort of work within it, and what open source can do to remain competitive for all companies, not just big enterprise, but all the way down to small startups as well. So in recent years, we've witnessed an explosion in open source observability tools, things like Grafana, Loki, Prometheus, Tempo, OpenTelemetry, and plenty more. Each of these tools, they excel in their own domain, whether it's metrics, whether it's logs, whether it's traces, instrumentation, etc. However, integrating them all into a cohesive observability stack actually does present significant challenges in itself, mostly around things like fragmentation and integration. So each tool often requires its very own data store, its own query language, maintenance protocols, etc. So for instance, Prometheus uses its own time series database and then PromQL for querying your metrics, while things like Loki employ a completely different storage mechanism and LogQL for log queries. This diversity necessitates teams to manage multiple different data stores as well as learn all these various different query languages. Again, all of these individual things increase operational overhead. Now, moreover, scaling these tools can be very, very complex. So like telemetry data, or especially logs, they can be very bursty. So maybe doubling or even tripling during production incidents. And without scalable architecture and things like data queuing mechanisms like Kafka or RabbitMQ, systems risk being overwhelmed precisely when the insights are needed the most. So the key question here is that given the challenges, we have to ask, can we unify observability without sacrificing the flexibility that comes with open source? Is it possible to have a cohesive system that integrates completely seamlessly while also reducing that operational overhead and maintains that adaptability that open source tools offer? So addressing this question is crucial as we strive for more efficient and scalable and user-friendly at the end of the day observability solutions, especially considering the fact that our stacks are getting more and more complex every year. So while open source observability tools like Prometheus and Grafana that we mentioned, they are free to use, they come with lots of hidden costs that organizations often overlook, especially early on when they're deciding what to use. So the operational overhead is the primary factor here. Implementing and maintaining all of these tools demands significant time as well as a lot of expertise. So teams have to handle things like the setup complexities, the continuous scaling, as well as debugging challenges. This operational burden that can divert resources from core business activities, which leads then to considerably increased expenses over time. It's a trap that a lot of, especially startups and scale-ups, fall into. Now, I mentioned the infrastructure complexity. So like a typical open source observability stack has, as we mentioned, multiple storage engines, time series databases, object storage, as well as various indexing systems. Now, managing this like Frankenstein infrastructure, it adds even more complexity on top of what you already have.
Sometimes
Not to
the voice,
mention, pardon, sorry? Not to mention the
sometimes the
latency.
voice is missing.
Not to mention the latency issues that it can add to things like data duplication. So this fragmented approach can hinder efficient data correlation as well as slow down incident response times, which is the whole point of a good observability stack. So when people hit this point where the managing of their system becomes a job in itself, what do most companies do? They turn to managed solutions, right? And to mitigate these challenges, they'll opt to pay for a single unified managed service instead. While a lot of these services offer ease of use, which is their main selling point, they come at very, very steep prices often, and this leads to things like vendor lock-ins by being incompatible with most alternatives. So the idea of moving away from one of these becomes a whole project in itself, rather than giving you that flexibility that typically comes with running open source platforms. The reliance on a single vendor, it can limit the flexibility and make future migrations very, very expensive. So what's the trade-off here? Organizations face this dilemma. They can either invest heavily in managing their big, complex open source tools, or pay that premium for managed services with reduced control. Both options have significant costs, and this emphasizes the need for solutions that balance that operational efficiency with the flexibility and cost effectiveness. Now, in the realm of observability, a lot of organizations turn to the big providers like Datadog, Grafana Cloud, New Relic. While these services do offer the convenience, they come with a big downside. We mentioned the vendor lock-in a moment ago, and this dependency, it really can limit the flexibility that you have with your system as well as control over your own data. Now, on top of the individual services themselves, there are potential geopolitical implications that need to be considered, especially around things like GDPR and the Cloud Act in America. So a lot of the leading observability platforms that are available right now are US based, and they're subject to US regulations, especially the Cloud Act, which is the Clarifying Lawful Overseas Use of Data Act. Now, this act actually allows the US authorities to access data stored by any US service provider, and that doesn't matter where it's stored in the world. So you could be storing it in a data center in Europe, but if the overarching provider is American, you are subject to the Cloud Act and the potential intrusions by US authorities. This has raised considerable concerns, especially among European organizations, regarding data sovereignty and privacy. For example, the European Data Protection Supervisor has already highlighted the potential conflicts between the Cloud Act and GDPR in the EU. There have been quite a lot of recent developments around this. Mostly the most notable one is the Apple encryption dispute. A recent example illustrating these involves the UK's demand that Apple create a backdoor to access encrypted data on its cloud storage systems. Obviously, they refused, and it's ongoing. This request has led to investigations into potential violations of the Cloud Act, which just underscores that complex interplay between national security interests and data privacy rights of individual companies. So this leads us to the European dilemma, or the global dilemma, excluding the US in this situation. There are very limited alternatives. European companies often find themselves with, as I said, no alternatives that respect local data sovereignty. This dependency on US-based providers does not only poses compliance challenges, but also raises strategic concerns about Europe's digital autonomy. As is highlighted in recent discussions, Europe's reliance on these US tech giants is viewed as a critical weakness. And this has prompted calls for investment and independent and secure digital infrastructure in Europe. So the conclusion here is that we want observability, but without the geopolitical trade-offs. While managed observability platforms offer operational benefits, they come with all these hidden costs related to both vendor lock-ins as well as the data sovereignty issues. It's super important for organizations to very carefully assess these factors and explore solutions that align with both their strategic objectives and their compliance requirements. So we've outlined the main problem here, and open source observability today is a mess of fragmented tools. It's expensive, not just in dollars, but in the time that's actually spent managing all these multiple databases, the scaling the infrastructure, and debugging various quirks. In the end, many companies still end up locked into very expensive managed services. But let's just challenge the assumption. Is this how it has to be? Because it definitely shouldn't be. Open source isn't meant to mean you're on your own. It's supposed to mean flexibility, but without compromise. But when we look at how the industry has evolved, we do see a pattern. A company will adopt something for their metrics. Let's just use Prometheus in this example. Then they realize it doesn't scale that well on its own. They then either pour resources into running it themselves, or they pay for a hosted service. They'll then add something for logs, but again, like Loki, for example, it's very slow on large data sets because it lacks probably various indexing. And again, they can either throw money and hardware at it or hand over the problem to a managed provider. And then tracing comes into the picture like Jaeger or Tempo. And now you've got 3 different storage backends to deal with, and the problems just compound themselves, and it becomes even more stark. Suddenly engineers aren't actually innovating or focusing on what they're meant to be doing. They're just firefighting their own observability stacks. As I said, this is not how it should be. Observability should be a first-class citizen in modern infrastructure, not an afterthought that only gets attention when performance starts to degrade. So how do we address this? How do we fix it? We need observability that's built specifically for performance and scalability, but from day one. So without forcing companies into like walled gardens, as it were. Not to purely plug ourselves, but this is exactly what we've tried to do and tried to bridge the gap by focusing our infrastructure on a polyglot unified approach to observability. The goal with Gigapipe, for example, is an example, and just as an example, was an open source tool to maintain that compatibility with every query language. So whether it's PromQL, LogQL, OpenTelemetry, but without the complexity of managing them all in different databases. A system where logs, metrics, and traces aren't siloed across different technologies. They all exist in one high-performance backend that's optimized for both speed, efficiency, as well as scale. That's the future that at least we think we should be building, that observability should be an enabler and not a burden. And it starts with the rethinking of the actual architecture behind it. So, as I said, open source shouldn't mean stagnation. It should mean a better way forward. Now, if we step back for a second and just look at the actual practicalities here, like nobody really wants to build a company to manage monitoring tools. Nobody wants to hire engineers thinking we need a whole team just to keep our observability running. But that's exactly what ends up happening. And if you don't want to spend half your time fixing your own stack, as we mentioned, the alternative is a managed service, which, as we've discussed, often leads to vendor lock-ins, steep prices, and very limited flexibility. And not to repeat myself, but data residency and compliance come into it constantly. This is where we think that open source has to step up. We need a solution that is truly independent, so not tied to any one jurisdiction or one cloud provider, fully self-hostable as well, so that people who have to keep their data on-prem can do so without compromising on features or support. And then a drop-in replacement, so that switching doesn't mean rewriting half of your code base. That flexibility on being able to switch between providers is key to actually attracting people to try new ways of working. And as I just mentioned, this is exactly what we've tried to do with Gigapipe. We're not saying use our product because it fixes all your problems. We're just saying that this is the direction that open source observability needs to go in if it really wants to stay relevant. Because here's the truth. So if open source tools don't evolve, people will move to managed services. Not because they want to, but just because they don't have the time or the resources to manage the ever-increasing complexity themselves. Like even 10 years ago, stacks were unrecognizable to what they are today. And when that does happen, we essentially lose what made open source great in the first place, which is control, transparency, and choice. So again, the real question isn't just what's the alternative to the vendor lock-in, it's how do we make open source the obvious choice again? And that brings us up to the next big piece in the puzzle, which is storage, because the way that we store and query observability data is where the real performance gains actually happen. So for years, observability has been built on separate storage engines. Again, I'm just going to use Grafana as the example, but logs go to Loki, metrics, Prometheus, traces into Tempo, etc. And each different databases, as most tools do, have different indexing strategies and different query languages. This works, but it does come at a big cost. You end up with duplicate data across your different stores, not ideal. Queries end up being very slow because they have to piece together information from multiple different backends. And scaling just becomes a nightmare because you have to scale each of them separately, often leading to a lot of wasted resources because they won't always scale at the same rate. This is why we recommend a single unified data store for everything. I'm not promoting any specific databases here, but for the sake of this example, like we chose ClickHouse as the backend. ClickHouse wasn't even built specifically for observability. It's a general purpose, high performance analytical database. But what makes it perfect for logs, metrics, and traces is ultra fast queries, fantastic compression, and much better correlation. Since logs, metrics, and traces all live in the same database, cross queries become instantaneous rather than stitching together results from separate systems. So, and that sounds perfect, right? Like fixed all the problems. But again, it creates its own issue because while a single database simplifies everything, it also introduces a new challenge, which is now dependency. Relying on one database for everything is again, it's a trade-off. You're again relying on one repo and one team of contributors, even though it is open source. That's why, from our point, we're trying to relieve that issue as well. That's why we're already working on adding additional options. So ClickHouse is a fantastic foundation for us, but it shouldn't be the only option. We're exploring things like DuckDB as other high-performance open source alternatives, and we're keeping the door open so for as many users can use the platform however they see fit. Now, because flexibility doesn't have to mean sacrificing performance, the goal is to offer a range of open source options so that users can choose the best tools for whatever their needs are without getting locked in and actually use it the way that they want. The key takeaway here is the problem with traditional observability stacks isn't just there's too many tools. It's that there's too many tools that don't talk to each other efficiently. The unified backend does change that, whether it's ClickHouse, DuckDB, or something else. The future of observability isn't about managing multiple storage engines. It's about finding the right one that makes everything just kind of work. And when that happens, observability stops being an operational burden and it starts being an actual advantage to your business. Which brings us to the next critical question. So if storage is handled, what about performance? Because even the best database is only as good as its indexing strategies. Now, we've established that the unified data store can simplify our observability stack. However, the efficiency of the system does hinge on this factor, the indexing. So indexes are akin to a table of contents in a book, right? They're enabling rapid location of specific information without scanning every single page. In databases, effective indexing can drastically reduce the query times, enhancing performance and responsiveness. Now, a lot of log tools do opt for schema-less designs, storing logs without any native indexing. Now, this simplifies ingestion and it does reduce your overall storage overheads, but it presents challenges, especially with data retrieval. Most teams will probably hit bottlenecks with querying long before they hit any ingestion volume issues. So with query performance, without indexes, you've got to pretty much scan huge volumes of data to fulfill search queries, leading to things like increased latency mostly. Users have already reported significant delays when querying extensive data sets, with some experiencing things like timeouts or high CPU usage during searches. And obviously, it leads on to scalability concerns. As your log data grows, the lack of indexing just exacerbates this performance issue, making it very challenging to actually maintain the efficiency in large-scale environments. Not indexing anything means queries will be looking up 10 times more data than is actually relevant to you. A simple and well thought out indexing strategy means that you will only ever query the data that you actually need. Metered options, especially here, will penalize and charge you a lot more as you end up paying compute process for 100% of the data, while you actually only need to query sort of 10, 15% of it. On the other extreme, indexing everything leads to ingestion and storage degradation. So it's a balancing act of figuring out the right scale. With us as the example again, we leverage ClickHouse's approach, which is the comprehensive indexing. It employs a robust indexing mechanism designed specifically for high performance analytical queries, but that means it uses things like sparse indexes, which means that it allows it to skip large data blocks that don't actually meet the criteria of your query, which significantly reduces the amount of data that's being scanned. Also in columnar storage, which means that the column-orientated architecture ensures that only relevant data columns are ever read during queries, again, enhancing speed, enhancing efficiency. To go one step further, the Gigapipe layer on top, we actually use light indexing to partition the data so that we're never over querying. You only want to ever use the compute to query the data that you actually care about. Find that section immediately, and then query the individual data slices. That's all done in real time. So the properly indexed unified backend drastically improves response times, enhancing the efficiency and the scalability of all your observability systems. By leveraging databases like ClickHouse, for example, which prioritize comprehensive indexing and optimized storage architectures, organizations can achieve much, much faster query performances and a more responsive observability infrastructure. So we've gone through the challenges and the innovations in this space. It's evident that the tools we choose should empower us, not just constrain us. So this brings us to the one pivotal principle, and that's open APIs and the elimination of gatekeeping. Now, open APIs are the backbone of a flexible observability ecosystem. They ensure that tools can communicate seamlessly, fostering an environment where integration is straightforward and customization is just expected. By embracing open standards, organizations can avoid the pitfalls of that vendor lock-in and maintain control over the data as well as their workflows. So extensive compatibility means that there's no need for proprietary formats, for example, or convoluted data transformations. Your existing observability setup can integrate seamlessly, preserving your current workflows while enhancing functionality. This also means that you're always free to move away to something else without starting all over again, maintaining that aspect of choice. The true strength of an open observability platform lies in this freedom that it offers to users. With the open API approach, you can continue using familiar tools, whether you're a fan of Grafana or any other visualization tool. Open compatibility means that you don't have to abandon the interfaces that you already know and you already love, and have probably spent a really long time configuring. The flexible data storage means that you can actually choose where your data resides, whether it's on-prem, in the cloud, or in a hybrid setup, for example. This flexibility means that compliance with data residency requirements and aligns with your actual organization's infrastructure strategy. And finally, seamless migration. The absence of artificial barriers means that you can actually migrate your data and your workflows however you need, without being tethered to this specific vendor's ecosystem in one similar to like the all-in-one systems. Now, there are broader implications here as well. So embracing open APIs and eliminating gatekeeping is not just about the technical flexibility. It's about fostering innovation and collaboration. So when tools are designed to work together without friction, teams can focus on deriving insights and actually driving value rather than wrestling with integration challenges. Moreover, this openness democratizes observability, making it accessible for organizations of all sizes. So small startups and large enterprise can both tailor their observability strategies to their unique needs without actually being constrained by the limitations of a closed system. The journey towards a more open and flexible observability landscape is not just a technical shift, but also a cultural one. It's one that prioritizes user empowerment and fostering interoperability, as well as championing the original principles of open source. So how do we keep users happy in the open source world? Whether it's hosting it yourself or using a managed version, how do we actually ensure that users choose open source observability solutions, not just because they have to, but because they actually want to? The answer is, for us, is relatively simple. That is, focus on making open source tools better every single day. And we do that together as a community. Open source software thrives on collaboration with contributions from developers, engineers, and organizations from all around the globe, not just the original creators of the repo. It's not just about building software, it's about building sort of a movement that actually empowers users rather than just serves commercial goals. That's why community-driven development is so important. In the open source world, users don't just consume, they participate, they contribute, and they shape the future of tools that they actually rely on. This is a key differentiator between open source, even if it's managed open source, and closed systems. In an open source community, the software evolves to meet the actual needs of its users, not just the strategic goals of the vendor that owns it. So remaining truly open source, how do we do this? This means that no hiding behind things like license agreements. We encourage people to use the product however they see fit. If you want to fork it and make changes and do that, feel free. If you want to use it to power your own managed service, go ahead. That's the whole point. There's nothing that limits you from doing this. We want to spread adoption, not ring fence it. So for those who don't want to manage their own observability stacks, as I mentioned a minute ago, there are managed open source options available where you can still use and gain that flexibility without the reliance on the vendor. These solutions provide the benefits of open source, so flexibility, transparency, no lock-in, while taking the operational burden off of your shoulders. You still get to keep control over your data, but you don't have to worry about the day-to-day management of it. At the heart of this philosophy is a very simple truth. We don't believe in keeping clients because we lock them in with hidden pricing traps or proprietary features. We believe in keeping clients because our solution is the best option for them, and it's built by the community to serve everyone's needs. So as open source isn't just a model. It's a commitment to continuous improvement, to user empowerment, and to community collaboration. And as long as we keep clients happy by staying true to these principles, open source observability will continue to thrive, it'll grow, and hopefully it'll evolve with the growing needs of the market. So as we've gone through today, the observability space is at a critical crossroads. Right now, the market is very dominated by US vendors, creating a landscape where choice is relatively limited, and vendor lock-ins remain a real problem for all companies. This dominance often comes at the cost of privacy, control, and in some cases, even performance. The current state of affairs highlights a pressing need for more competition in this space. Europe actually has a unique opportunity here to step up and provide that alternative. We could build observability tools that actually prioritize privacy, performance, and transparency. These tools won't just be designed with technical excellence in mind, they'll be shaped by the values of the open source community, ensuring that they evolve in response to user need and not driven purely by corporate interests. What makes open source observability stand apart is the ability to innovate freely without the constraints of that vendor lock-in. By supporting independent, open solutions, we can foster a competitive and diverse ecosystem where privacy and performance go hand in hand. This is where Europe, with its strong data protection laws and thriving open source community, can truly lead the way. And the best part is no one does this alone. We collaborate with many different open source teams and tools to make the ecosystem open and compatible and as an easy match for any of the different situations as possible. So, yeah, sorry if I ran through that a bit quickly. I just want to thank you all for listening to our thoughts on the future of the open source observability market. As I mentioned before, Gigapipe is an open source observability platform with a unified data layer to make that data correlation and high performance much more attainable. We also have fixed unmetered pricing when it comes to our managed options, so that you're more than welcome to try it out. So please get in touch. We have a huge community of our open source users and easy trials for our managed versions, and that's obviously how we financially support our open source work as well. Great, yeah, my details are up on the screen if anybody wants to reach out or you have any questions afterwards, or we can go through the live questions now with Anastasia.
I'm here. Yes, I'm here. Thank you for your session. Actually, right now I'm checking questions in LinkedIn, and we don't have any. And here as well. Maybe we will find some.
That's fine. If anybody has anything they want to know later on, just feel free to message me directly. You can send it on Slack or just email me, and we're happy to get back to you guys at any time.
Oh, yeah, we have one question. What is the relation between Current and Gigapipe?
So Querion was the original open source observability tool that was built years and years ago. The Gigapipe and the original team behind Querion merged a few years ago now, and Gigapipe became the Now the full querying essentially became Gigapipe. It is the full platform which links all the different tools together in one place. Querying is just one aspect of the Gigapipe observability suite, but it is the original build behind what is now Gigapipe's open source observability platform is the original querying, and all the same creators are involved as well.
Okay, and the second question is, could you share any customer story?
Yeah, sure. So the frequent ones we get are people using, because the main ethos behind what is now Gigapipe is that drop-in replacement. The idea is that it is a it's easy to swap from any existing vendor over to Gigapipe because we make it compatible with all different query languages and ingestion protocols. So a lot of the time, people start with things like Grafana Cloud, for example, where the initial pricing might seem great with the free tier, and then suddenly someone starts scaling and their costs are going out of control. It's not that they dislike using Grafana. In fact, most of the time they like it and they want to keep using things like the open source Grafana client for querying the data and things like that. But they need something that is more scalable because we focus on using an unmetered model, which basically means if you wanted to use the managed version, for example, you have X compute, but then you will never be penalized for how much you query or how much you ingest. It's purely based on compute limitations. That's probably the most common use case that I think we get is people moving away from similar things like that. We do similar things with Datadog and New Relic. We have a lot of very compatible formats. So that the whole goal is that on the client side, we want to limit as much work as possible so that if you did want to even trial a change, you can do that in absolutely no time. It doesn't require an entire rebuild of your backend in order to try a new solution. It's that interoperability and that open flexibility when it comes to switching between providers is what we really focus on, not just to attract clients, but also so that people never feel locked, so that they feel like if in 2 years we wanted to consider something else, you can absolutely do that. It's not how we want to keep clients.
Okay, thanks. One more question. What is your view on login schema? Is it possible to allow applications to use structure logging without enforcing some type of schema on the backend?
Yeah, so for the more technical questions, I will take those and I'll pass them on to our dev teams. I'm a non-engineer myself, but when it comes to the different formats, again, the whole idea is that we try to allow as many different ways of working as possible. Whether your storage is going to be directly in ClickHouse or if you want to use like Parquet formats in S3 or things like that. The whole idea is that the formats that you're able to ingest directly into the database are not limitless, but a lot more open than most. I'll come back to you specifically with the answer from the devs on the actual schemas themselves, but we do a lot of work around different indexing strategies as well, whether or not it's on the database level or on the querying level.
Okay. And questions from me. What is your segment of market? Is it big tech, fintech, or
Sorry, say that again, sorry?
what is your segment of market? Like mid-sized firms, what kind
So
of?
the original open source version that was created was actually created for large scale, right? But we always had it in mind that we wanted it to be applicable for small startups as well as enterprise companies. So we started at the top and worked our way back. So the ease of use and getting set up quickly is great for startups. And a lot of the time, the smallest possible instances run it very, very efficiently. Because we do leverage ClickHouse on the back end, it's hyper performant from the start. But it was built initially for enterprise clients. So volume and scaling was always at the heart of what we wanted because we were trying to avoid the traditional pitfalls that a lot of people fall into with we start small scale and then it's unsustainable. The idea is that this is sustainable at scale, whether you're using the open source version or the managed version. And typically we deal with a lot of SME to enterprise, but the self-service aspect of it is that a small startup can just sign up and be up and running within an hour and have all their data ingesting directly into a unified backend. So we try to couple that flexibility with that potential scalability as well. Sorry, I just seen another question there. Can Gigapipe integrate with Grafana? Yes. So a big part of the whole compatibility thing that I mentioned is it's completely open so that you can add your data source to any data interpretation software that you like. So Grafana, we'll just use that as an example. We have a unified endpoint, so you don't have to use different ones, whether it's logs, metrics, or traces. And when you add your data source with that unified endpoint for all three, you just use your key, secret, basic auth, however you want, and you actually add it as it basically behaves like whatever it is you're trying to read it from. So you can add a Prometheus data source, put in the unified URL, and then put in your keys, and it'll work straight away. Whether you're using it for logs, metrics, or traces, they all read from the same point, but then our proxy will figure out which data set that you're trying to work from. A lot of clients who come from either using Grafana or something similar, they maintain the exact front end that they're using already to do their queries. And that means you don't have to change things like dashboards. You don't have to rebuild flows and alerts. You're just changing the data source in the back end, and then everything runs as is. If you're coming from something, like let's just use Grafana as the example, you can literally be set up and running in like 15, 20 minutes if you know what you're doing.
Thank you. And actually no questions in LinkedIn. So guys, please ask
Great.
your question.
No worries. That's fine. As I said, if you think of anything in the long run, feel free to message me directly. But I always have to talk to people, whether it's about support with using the open source suite or if you're looking for something more managed.
Okay. Then thank you guys for this session, and we're glad to see you in the next webinars as well. Thank you.
Great. Cheers, guys.
Yeah. Thank you. Bye-bye.